our brain needs to sleep every night, and during sleep, the brain resets, repairs itself, and rejuvenates so that we are a new person every single day. But over the last 25 years, one big discovery in the field of circadian rhythm is just like our brain has a clock, almost every organ in our body has a clock. So that means every organ, just like the brain, also needs a good downtime to repair, reset, and rejuvenate. So that means we as humans, we are programmed to eat only during the wakeful hours for few hours. And then our body, our stomach, our gut, our heart, lungs, all these organs, they need that downtime to repair, recover, and rejuvenate from the stress of digesting, assimilating the nutrient that we eat. So, based on that idea, we did a very simple experiment. We asked, um, by keeping the same number of calories, if we eat at this different time, then what happens? And what was surprising was after 18 weeks in the first experiment, we found that the mice that ate any time, they became obese, diabetic, they had liver disease, they have heart disease, all kinds of diseases, chronic diseases that we often hear about. But the mice that ate in a time restricted fashion, but the same number of calories from the same food, were completely protected. And this was mind blowing to us because in the entire history of nutrition science, we knew that the quality and quantity of nutrition matter. But here, we did not change quality, we did not change quantity. The only thing that we changed was give the mice enough time for their organs to repair, reset, and rejuvenate. And by doing that, they are completely protected from disease. Our stomach actually produces a huge amount of acid, digestive juice that breaks
Mm-hmm.
down all this stuff. Literally, the gut lining, nearly 7 to 10% of our gut lining cells actually get damaged or destroyed during this digestion and nutrition assimilation process. And that lining itself, to begin there, that lining itself has to be repaired every night. The second is, we eat a lot of stuff that our body actually does not need. For example, our body actually does not need vanilla flavor or any flavoring agent that you use, many spices, many food coloring agents. There are a lot of stuff, even in natural product, even in green vegetables and tomato and everything. So those are unnecessary products, and some of them do damage our cells, damage the inside of the cells. And third thing is, when we break down all this nutrient, then we also produce a little bit of toxin. And when you're eating, we also eat some bacteria and fungi, and then some of them are good, some of them are bad. So every day there is some stress of digesting and assimilating nutrient, and our
Yeah.
body, literally what people say, you have to detoxify. And it's not toxin that we intentionally eat, that is part of our food. So that's why our organs have to repair, reset, and rejuvenate every single day. There was a lot of criticism from clinicians and nutritionists who just poo-pooed our work, saying, hey, humans don't eat like mice. We don't
Yeah.
wake up in the middle of the night and we eat. Most humans eat three square meals within 12 hours interval. So your work has no human significance. Nutrition science never ever, and I can emphasize this word, never ever longitudinally looked at when people eat over several days, because we know that we eat differently between weekday, weekend, and what we eat, when we eat, all that stuff changes. The gold standard of nutrition research is asking people, what did you eat in the last 24 hours? And it doesn't take into account how much variation is there from day to day, how many times they're
Mm-hmm.
eating in the middle of the night. So then it forced us to start a very simple app that is now My Circadian Clock. That's the name of the app. And we built this app in the lab, and we invited 150 people from San Diego area who were not doing any shift work. And then we asked them, we do very simple thing. You just open the app, take a picture of what you eat, and then press save. We didn't ask them to say what is the portion size, what they eat, and all that stuff. Just 3 click. And they had to do it for 3 weeks because we wanted to know how they eat during weekday, weekend. To our surprise, what we found is nearly 50% of adults ate for roughly 15 hours or longer. So that means if they had their first cup of coffee with cream at 6 a.m., the last glass of beer, wine, or milk was happening after 9 p.m. And they were doing it at least 2 to 3 nights in a week. When you fly from East Coast to West Coast, your brain circadian rhythm gets messed up and you have jet lag. Similarly, even for 1 or 2 nights, if we eat late into the night, that messes up our circadian rhythm. So
Mm.
that was an aha moment. Like, yes, half of the humans actually eat like mice, and they eat really over a long period of time. And only 10% of people actually eat for less than 12 hours. Or even if you're eating for 12 hours, 6 a.m. to 6 p.m. So that means after the last bite at 6 p.m., the stomach is still working on digesting that food, because digestion doesn't work like a magic, like in 2 minutes, it's all digested. It takes at least 5 hours. Your stomach is still working. So your 6 p.m. dinner is being digested until at least 11 p.m. or midnight. And that's when your stomach is getting rest. You go back to repair and reset mode. And then if you're starting again at 6 a.m. in the morning, then your stomach is getting only 6 to 7 hours of quote unquote sleep, because that's when it's actually having rest time. So then we asked, well, people who are eating for 14 hours or longer, we asked them, hey, can you do a simple thing? You don't have to pay attention to what or how much you're eating. You just have to pay attention to when you're eating, and then try to eat within 10 hours. We didn't tell them that they can cheat, but we expected that once or twice they will cheat. And what we found was they could actually stick to this 10 hours regimen. And this was, again, another eye opening, because, I can come up with a new regimen saying that, if you do 10,000 steps every day, then you will reverse your diabetes. But then how many of us can actually do 10,000 steps for even 5 days? It's very hard. One key important piece is whatever we find, can people practice it? So they
Yeah.
practiced. And we found that they lost modest amount of weight, 3 to 4%. But these are not obese people. They were just a little bit overweight. And after 18 weeks, we let them go. And then after a year, when we contacted them, we were surprised that they were still sticking to the 10 hours window. We didn't have to, they didn't have to, but they just loved it. And we asked why. And they said they were sleeping much better. They were feeling more energetic in the morning. And many of them who had stomach issue, digestion issue, those are gone. And the joints were less painful. When you ask people to fast, or when you ask people to restrict their calorie, count calorie, it's a very stressful experience. Not eating for a day is a very stressful experience. And people don't enjoy that. They don't do it every day. But eating within 10 hours, we realized that people actually enjoyed it. So that's why they
Yeah.
stuck to it. We have the luxury of knowing what else improves health. So, for example, we know metformin, for example, which mimics fasting, acts on a kinase called AMP kinase. That's a fasting induced kinase, triggers fat oxidation and a lot of different things. What we find is when animals do this time restricted eating, then their um, pancreas gets enough rest to prime the cells to produce just enough insulin when the mice start eating. So the pancreas does not produce excessive insulin during fasting time. So the fasting insulin level actually drops. In liver, our liver produces some glucose when we fast. It's known, because the liver has to produce some glucose that will fuel our brain, because our brain is dependent on glucose. But in type 2 diabetes, in many disease, liver disease, this mechanism that should be on only when the liver is when we are fasting stays on throughout 24 hours, as if the circadian rhythm in glucose production is non-functional. So that contributes to increased glucose, because the liver is producing glucose, we are eating, all the glucose is flooding our blood. And when mice do this time restricted eating, this process called gluconeogenesis, making new glucose, that shuts down during the eating period. So for half of the day, the liver is not producing excess glucose. And that might partly explain why the glucose levels remain normal. The third thing is, when I say this gluconeogenesis, that glucose is made by breaking down protein in the muscle. And if for half of the day the liver is not making that new glucose from breakdown muscle protein, then the muscle must be getting healthier. And that's exactly what we find. At least in half of our mouse experiments, we have seen the muscle mass increases under time restricted eating. And it's not only just dysfunctional muscle mass that is increasing, these are functional muscle mass, because these mice can stay on a treadmill for a very long time. They can exercise, they have much better motor coordination. And the same thing we find in fat tissues during the fasting time. there is enough drive or enough deficit of energy that the fat tissue now begin to break down the fat that's needed when we fast, and that fatty acid also comes to the liver, broken down again to ketone bodies, or ketogenesis happens, and that fuels the body. And all of these are interlinked, because for this process, for the fat breakdown to happen, one thing that happens in the liver is excess cholesterol gets broken down, and that's because the circadian clock in the liver becomes more strong, and there is one of the clock component, clock protein, that is actually responsible for turning on this mechanism to break down cholesterol to bile acids. So we break down cholesterol, and our bile acids level go up, which is pretty good for us. And some of that bile acids go to the fat cells, and they tell the fat cells that it's time to break down your fat, so that the liver needs some fat for making ketones. So now you can see that it's not one thing that happens during time restricted eating, at least 5 or 6 different things that we know it for now, and that list is continuing to grow. Most humans who do time restricted eating or intermittent fasting, sometimes they push it to too much, too extreme, and they may be reducing their caloric intake, or they may be reducing their protein intake. And one thing I must emphasize again and again is, in all our mouse studies, we make sure that the mice eat the same number of calories from the same food as the ad libitum or any time eating mice. So we are not reducing calories, we are not reducing any protein component or anything. And this is a huge difference between human studies and mouse, because many people inadvertently reduce their food intake. But there are other studies. For example, there are studies, well-controlled studies done on resistance trained athletes who did time restricted eating. The muscle mass remained constant. They slightly reduce their fat mass, and that's a very good example, because these people are very mindful. Resistance training athletes, they're very mindful of their food. They have tried their best to reduce their fat mass and build up their muscle mass. And when they did this time restricted eating, they didn't change too much of their nutrition quality, but still it helped them to reduce their fat mass and preserve muscle mass. Many people think fasting is a painful experience that can reduce nutrition intake. So that's why we created this app, My Circadian Clock. People can self-monitor themselves for a couple of weeks by not changing their eating habit. Just see when you eat and how much you eat. And if that is 16 hours, then even if you reduce that window by 4 hours and come to 12 hours, that's a very good starting point. Where are you right now? And if you're above, say, 14 hours, then try to bring it down to 12 hours. Try for a couple of weeks. And then you see, can you bring it down to 10 hours? Even if you can bring it down to 10 hours for 5 days, that's pretty good. Because once you can bring it down to 10 hours for 5 days, then your body actually trains itself. You don't have to tell your body. In the weekend, you'll notice that if you eat outside this 10-hour window late into the night, then next day your body will revolt. You'll have food hangover, as if your stomach forgot to digest your food, is punishing you. Then you'll come back to that 10 hours window. If we start, say, around breaking our fast 9 or 10 o'clock in the morning, then your last meal should be 5 or 6 in the evening. And then that's doable for most people, because you can still have one meal with a loved one. If you bring it down to 8 hours or 6 hours, then it can put some stress on social connection and other stuff. And then if you can do at 10 hours time restricted eating for at least 5 to 6 days, then that's pretty good enough. Because though in those 10 hours, what we're finding is many people who have high blood pressure, they reduce their blood pressure as if they're taking a blood pressure medication. The benefit is similar to taking a blood pressure medication. And then those who have mild hypoglycemia, like pre-diabetes or early stage type 2 diabetes, if they do 10 hours time restricted eating, then they see much better glucose control. It's almost like taking a low dose metformin. What we're finding is when people do 10 hours, particularly people who have pre-existing condition, because they are the ones who are going to see the best health benefit, they can sustain this 10 hours time restricted eating for up to a year. At least two-thirds of our participants can sustain it for 1 year without much hand-holding after 3 months. So we think that's a good sweet spot. And once you practice it, the benefit is, suppose say you do it for 3 months and then you fall off the wagon. So then that doesn't mean that you cannot go back, because you can always go back. And you know that this is one item in your health menu that you can always practice. You should be in bed for at least 8 hours, because being in bed for 8 hours will help you to find at least 7 to 7.5 hours of sleep, which is good for brain health, metabolic health, long term health. And also, people who sleep for 7 hours, they're more likely to live longer. That's also done on millions of people in many different continents over the last 20 years. So let's keep 8 hours in bed consistently. Then, after we wake up, that's the time when our hormones change. Our night hormones are slowly going down. For example, melatonin is slowly going down, and our day hormones, stress hormones, are coming back up. And that's the bad time to eat, because your organs are trying to adjust to a different hormonal condition. So that's why try to avoid food for at least 1 or better even 2 hours after waking up. So if you're waking up at 6 a.m., then it's better not to eat anything before 8 a.m. But in your last meal should be at least 2 hours before you go to bed, because these first 2 hours after meal, your body is trying to digest a lot of food. So there is a lot of blood rushing towards the core or your digestive organs, and your core body temperature is high. And it's not a good condition for you to go to a deep sleep when that happens. And also dim down your light so that your natural melatonin hormone goes up. So that's also another time when the hormones are changing their shift work. The night
Right.
hormones are turning on, the day hormones are going down, and it's not a good idea to eat. If you want to boost it up, then during daytime, go outside and walk for at least 30 minutes, because you'll get both exercise and bright daylight that improves your mood. Like, that's exactly what I discovered 20 years ago, and this was considered one of the top 10 breakthroughs of the year by Science magazine. We discovered the blue light receptor in our retina that senses blue light and resets our circadian clock. And then the same blue light receptor also connects to part of the brain that makes us more alert and reduces depression. So that means in practice, we should have daylight, which is the richest source of blue light during the daytime, to uplift our mood and reduce depression. That's the best antidepressant. It's plentiful and free. You just have to step outside for 30 minutes. And then at nighttime, we have to reduce blue light. So the reason why all your rectangular pieces of glowing objects, your TV screen, your laptop, your cell phone, all of them have this night shift feature is based on that discovery that we made. And if you reduce blue light, crank up your orange light for working, then that also helps you. You should not have any bright blue LED in your bedroom or in your kitchen or your living room. That's what we do. We have only the old style, very dim light in all of these places where I am in the evening. I don't actually wear the blue blocking glasses, but maybe I'm still producing enough melatonin that I don't need that. But maybe when I get older and my body cannot produce enough, or maybe I'm more sensitive to light, then I'll do that. As we age, one big thing that happens is our melatonin level drops precipitously. So a 60-year-old makes 10% or less of melatonin than a 6-year-old.